All right, good morning and happy Friday. I'm planning on doing the LeetCode daily challenge for today, August 4th. Oops. Hold on, let me share my screen here. Share screen. Here we go. Okay. All right, so the fourth word break. Okay. All right, so it is 8:46 in the AM. And I'm pretty sure I saw this one already, right? The game plan. Put dictionary. Oops. Put dictionary words into a hash set for O1 lookups. Oops. Right, constant time lookups. And then we can try each one. Right, plus DFS to try them all. Right, so we'll return true and propagate true. Right, return true and propagate true as the recursive stack unwinds. If and only if we can reach n. Right, so for each I index starting position, for each word, the dictionary have length k. Maybe try them all. Okay, so then I go to I plus k for each next. Okay, so yeah, the word length is only 1,000. There's 300 words, so this seems like a decent game plan. So we'll just call it an array of character, or actually no, this is okay. We'll just call it the string as uppercase, and then an array of words. So our set, what's been seen is a set of all those words that go high 0. N is the cardinality input string s, right? So if I is equal to that, then return true. And we'll propagate true as we go. Okay, so then for each candidate and actually let's do this. Try length k as we go, right? So for k in the range 1 to n inclusive. So let's do this. And then it's cardinality this guy. Since I'm using it more than once, might as well see it here. 1 to n inclusive. If I plus k is less than or equal to n, and s of I to I plus k is in seen, and go I plus k, oops, and return true. Right. Otherwise, return false after we retry them all. Okay, and then return go. Something like that. Okay, so it should be true, true, and false. Uh-oh. S is not defined. Okay, capital S. Okay, that looks legit. And then we should be able to memorize this thing too, right? It might run faster. Actually, let's just submit it without the memoization. And then we'll submit it with the memoization. So memoization is basically using the past solutions to formulate the future. As a recursive stack on lines, we don't have to solve the same overlapping subproblems more than once. Okay, so that does TLE, and then this should be accepted with memo, right? Okay, cool. So that was accepted at 8:50. It's about 4 minutes for the implementation. And oops, implementation in Python 3, which is accepted. Yay. Okay, let's do this real quick in just C++, and then I'll go look at the previous solution I came up with. Right. So I did this in Kotlin JavaScript. Okay. I guess I could do this in Rust too if I want to. Oops. Yes is a vector of string. Let's shorten this up a little bit so it's not so verbose. So set is an unordered set for OR1 lookups. String, right? So set scene. A dot begin, a dot end. Okay, and then fun will be our recursive lambda. Turn the Boolean takes an integer value for the current ith index. It is fun to go. Go will capture itself in its own lambda, so we can invoke ourselves. Turn go 0. So it is size the cardinality input string s. So if y is equal to n, return true. Return false if we get to the bottom here. And then I just for each string length of k up to n. Right, we just do n minus I, right? So I don't have to do that conditional check. Oops, plus k. If this substring from I to length k is in the scene set, oops, and we can go there, right? Have this k, and we'll propagate that as a recursive stack of lines. Okay, something like this, and then we'll need to add a memo too, right? No, subster typo. That looks good. Okay, we don't want to TLE again, so let's do this. Create a memo. Okay, so if m.find I is equal to n by n, right? And we don't have a solution for it. We compute it once and then save it for later. Return m sub I equals true. Is return false. Okay, something like that should be accepted. I gotta create an instance of this map, which is our memo, right? Looks good. Okay. Yeah, so that should be accepted. Let's say 8:54. 8:54 a.m. Oops. Oh, I didn't mark when I started. Let's see. I guess I ended at 8:50. Okay, so 8:54. About 4 minutes. Okay. 4 minutes for AC and C++. Okay, so let's go look at previous solutions you came up with. Yes, dynamic programming is pretty cool. So IJ candidate, substring. Okay, I used K instead of J, and I still think K makes more sense. Just because I think IJ has a range where I think the IK is starting index I of length K. It's the same kind of thing, though. Oh, yeah, I didn't even think about turn it top down, bottom up. So that's cool. Let's do that real quick. Right, so this is top down. memo. So as the recursive stack unwinds, you go from right to left instead of left to right. So Orion range reversed. Orion reversed range. Right. So then our memo will be DP is false times n plus 1. DP sub n equals true is our base case. All right. So here would be our memo. It's equivalent to this guy, basically caching the responses as we go. All right, and then we can let me try to just grab this so y'all can see the transformation as it occurs. All right, so the DP state, instead of being stored in the recursive stack as it unwinds, will be stored explicitly in the DP memo. Here, DP state for I equal true. Otherwise, it's false. So let's just do this. DP sub I equals this thing. Then we'll return DP sub 0, which mimics the recursive stack unwinding to the original problem itself. Okay, something like that. It looks like a decent solution. Uh-oh. Oh, oops, okay. I plus 1 minus n plus 1 minus I. So we don't go over. Oh, what did I? Oh, oops. Colon at the end here. I was going out of bounds. But I guess, yeah, I can improve this a little bit. Uh-oh. Okay, so that's not good. Sub I. Oh, is this guy or that guy? I guess or equals, how about? Oops, hold on. Or equals. Okay, that looks good. All right, that's cool. Let's do this in C++ real quick. I think it's a good practice and I think it's fun. All right, so we don't need the recursive stack. We don't need the memo this way, but we do need an explicit memo for our DP array. So it's DP sub n. One DP sub n equals true, which is our base case. Oh, actually, I can mark this up here real quick. Let's go back here to. All right, so where is our base case? Our base case is here. All right, so base case, and then here our base case would be this guy. Oops. That guy, our stop sign is our base case. Come on. What's this thing doing? Come on, you piece of junk. Yeah, I click this. Okay, well, let's copy and paste this. The heck is this? LeetCode IDE that's giving me problems, or what the hell's going on? Reload, okay. Holy cow. And this got to be a recurrence relation target. Oops. Recurrence. Another recurrence relation target. Map to this guy. Okay, so did I hit this? I don't know. Submit? I don't think so. Let's see. Looks okay. All right. Yeah. So mark that up a little bit with some pictures. Cool. right. Well, anyhow, where was okay, so here's our base case, right? Base case, and then oops. It's gonna be our memo explicitly. And then we'll mimic the recursive stack unwinding n-1 down to 0 inclusive. Grab this stuff. So we transform the implicit top down to an explicit bottom up. Okay, and then this guy, B, we can check for previous state explicitly, and our current state will then equal dp. So I over this guy, right? So this is our predicate. Okay, something like that. Oh, so yeah. And this is our recurrence relation target. Okay, I think that looks good. Right, that was cool. All right, cool. So I'll do this in Rust real quick and then I'll call it a day. So Rust, I'm just going to do bottom up. And the reason why is because I'm not able, or at least I don't know how to capture the outer scope and recursive closure within Rust. So if anyone knows how to do that, let me know. That'd be awesome. Currently, I am ignorant of that knowledge. Anyhow, let's shut this thing up and keep track of how long this thing takes. Rust is a special kind of programming language. And it gives me a really hard time. All right, so let s equal s dot chalmers dot collect into a vector of characters. Let's do this type BC characters. Okay, and then at the end, we're going to return dp sub 0. dp will be our memo. Let me build dp vector. N is the cardinality of the input string s. In with false. Oops, it's the value and then the size. Okay, actually, it should be +1. Okay, so dp sub n is our base case. It should be set to true. Here's our base case. Base case. This will be our memo. Okay, and then for in 0 until n non-inclusive reversed. Oh, minus I. Oh, crap. Ah, yeah, for k, right? So for k in range 1 until n inclusive minus I. Yeah, that should be good. Okay, so substring. If s substring I to I plus k non-inclusive is in the scene set. Let's do this. Functions hash set for O1 lookups. Scene equals a wonder if this hash set from a, if that works or not. Dot contains, it's this thing, and dp sub I plus k, dp sub I or equals this thing. Seen. From this thing, reference to string from the slice. I know 2, I know 6. Trig bound is not. Yeah, I'm not sure the syntax for this. A dot drain. Select the hash set of strings. Type set is a hash set of strings. Oops. Set string set. Size of the charge cannot be known at runtime. Bounded by this call. I don't know if this works or not then. See what happens. Satisfied. Scene that contains borrow is not implemented. We do not borrow it then? I don't know. Tried to borrow it. So I don't know. You can do this string referencing a dot map each into iter map each word as a reference. I don't know if that works or not. Scene as references contains map dot collect into a vector of these guys. I don't know. Mismatched types. Expected. I found a slice. That a reference to a slice? Reference to a reference? Right. Expected stir and slice. Yeah. Words. Then we have to create a string from each of these things and let's string from the slice. I don't know. String from slice. To string. Not very efficient, I don't think. I don't know what I'm doing here with Rust. Two string exists for slice, but trait bounds are not satisfied. Oh, I'm looking at a bad example, I guess. Reference it to string. Since disease. String from set of strings. When the size known at compile time. The heck? I thought that was what the reference is for then. Yeah, that's what I was thinking too, right? Yeah. Borrow it. Oh, borrow this thing. Oh, okay. This thing. That what it's saying? No. What did it say? Limited from chart. Ah, from array char slice. String from iter. Iter. Okay. From UTF-8. In a vector found a slice. Yes, I want to make a string from a slice. There's the slices, but how do I turn that slice back into a string? String first word. Yeah, it would be better to create a slice and compare slices, right? Nice. Okay, well, let's see if we can do that then. And if we can compare slices to slices, that would be nice. Train dot into enter dot map each string. Mhm. Reference. Reference to the whole slice. Select into a vector of string references. Specific character. Let's to a string. Ah, okay, so I want to get rid of that part then. All right, so S will still be a string rather than an array of characters. Come on. Expected or referenced. This part. Referenced. Reference the reference. Now return the value referencing it's borrowed here into iter string. Oh, yeah, we don't want to consume it. Just want to borrow it. Maybe that's okay. All right. First try. Silly, right? Occurrence relation target. There's a memo in our base case. All right, 902 to 919. That one took a while. What is that, like 17 minutes? Really struggling. That's cool, and whatever. It could be worse, right? At least got it eventually, right? Yeah, so that's cool. Set. How do I use that, right? Scheme. Oh, actually, yeah, I want this to be a hash set. Oops. I don't want it to be a vector. Surprising how fast it ran. 1 millisecond? That's pretty quick. Seen as a hash set. Yeah, okay. Yeah. Yeah, decent solutions. Let's see. Just post Rust here. This grab this guy. Bam, and then to do. Still need to figure this out if it's possible or not. How to implement a recursive closure which captures the outer scope. Oh, right. One of many things I don't know. So I'll add it to the bucket, I guess. And then it'll post this guy. Hopefully this is helpful. I don't really mark down all the other stuff really. Make it a little bit nicer looking maybe. Yeah, I really couldn't care less for J here. And I think it feels different. Like it should be K. But that's just me. Also, this would be a Boolean, I think, instead of an integer. Whatever. Yeah, things don't have to be perfect. That's good enough. Candidate, yeah. All right. Kind of verbose, but it works. All right, cool. And that's all she wrote. I'll catch y'all later.